This is code.org app lab, and I have built a Cody bird game, a Flappy bird game, and it's super awesome. I want to show you what it does, and then I'm going to show you how to make your own or make something better for your AP class, for fun. Let's test it out. Although mine's pretty awesome, so maybe not make something better, but you can at least make your own. Whoa! Uh-oh. So I got to 5 that time, right? Most of us know how Flappy Bird works. Let me just kind of dive into some of the details and the code. First, some real quick design stuff. I will post this, I am going to share this and post the link in the description and all of that. So you can check it out, look at my code, get some ideas, play it, have fun, build something awesome, okay? And then post a link in the comments to this. But in the description, I'll link this. The design stuff, I'll give you some tips here. For my pipes, what I used to create my actual pipes were the, not text input, they gave me problems, and buttons changed color upon click. I used text area, nope, I'm lying, I used label. Same with the caps for my pipes. I used label for that and just don't have any, I just didn't have any text in it, all right? These bushes are, all of my objects other than the bird are choose icons, and I picked one. And at first, honestly, with the bird, I even used for the bird the Twitter icon at first. So, but then I went and found a PNG, which is a photo online. You can find one too. If it's .png, it probably has a transparent background. So anyways, now let's get to the code stuff. I have a lot of variables up here, right? What they represent hopefully is somewhat self-explanatory. And what I mean by that is like X player is, well, the player's X location, player's Y location. We're going to set the score to 0 to start. The pipe speed is just what it says. It's how fast those pipes are moving to the left. And then award point, that will make more sense later, but obviously right now it's set to true, true, and true. If it's set to true, when we pass a pipe, we get a point, and if it's false, we don't. You'll see what I mean. Pipe 1, so these are arrays, right? These are lists, and the reason I made pipe 1, pipe 2, pipe 3, pipe 4 arrays is because I needed to include the cap and the actual tube of the pipe together, and that's what I did here and here, okay? X pipes 1 and 2 is the X location because they are going to have the same X location as they move, right? So for 1 and 2, pipe 1, pipe 2, yeah, these loop around. And then pipe 3 and 4, same deal, same X location, arrays, pipe 5 and 6, and then steps is how big my bird's jump is, I guess you could say. All right, now the on event. So on the event of me clicking the start button, what happens? This function executes. So I click start, and what happens in this function? Well, if get property start button hidden, because notice the start button hides right away. So if it's hidden, like right now, I don't want the start button to run again. I don't want this on event function to let you click start more than once, because you would start going really fast because you keep telling it to start moving the pipes. So first I make sure that that it's not hidden, right? Because exclamation point means not. So if the start button hidden, we're asking the computer, hey, is the start button hidden? And if the computer says true, it's hidden, the exclamation point will turn that response of true to false. It means opposite, right? Exclamation point's a not. So if it's false, then we won't run the pipes. But hey, if it's not hidden, right? The computer says, is it hidden? The computer says false, it's not hidden. Well, false into false is true. And if it's true, we'll move the pipes, then we set it to hidden. So moving the pipes, that's what happens automatically. I used a time loop for this. That's a control function. In the time loop, first off, I set the gravity, right? And I used comments to kind of explain. The Y player is going to be equal to the Y player plus 1. What's really cool about a time loop is this is how many milliseconds go in between each time it runs. So right now it's 15 milliseconds. To get you how fast that is, an idea, 1,000 milliseconds is a second. So this is going a whole lot of times a second, and that gives it the animation effect. Okay, so let's see. I'm slowly decreasing the player's height, right? That's my gravity. And once I use Y player and I keep changing it, I set the Y player each time to be going down, right? Set property player Y Y player. So each time I add 1 to this, because 400Y is the bottom, I'm pushing the player down as we go. Then adjust pipe X values. So here's our X values for 1 and 2, 3 and 4, 5 and 6. Now, it's kind of standard here, right? So I take my variable and I say, okay, set the new value equal to the old variable minus the pipe speed, which is what I controlled up here. It's a 2. So each time this runs, we are going to take 2 away and move our pipes along. However, the weird thing is this. I'm adding loop pipe X pipes 1 and 2 and 0. Let's go see what this is, right? Green is a function, so loop pipe. The computer's going to be like, what? Loop pipe? And it's going to look for our function, hopefully, which is loop pipe. Check if a point was scored, loop to the other side. So what I'm doing with this is it's useful in 2 ways. 1, it awards a point if a point is scored. But 2, if the pipe's off screen, it's going to loop it back around so it looks like we have infinite pipes. So, and keep in mind, the bird never goes forward. The bird only goes up and down, right? There's not movement of the bird otherwise. It's just the pipes moving that make it look like there is. So, all right, loop pipes. Let's see. We have this change X. All right, so what change in X is this loop pipes going to do? Well, first I'm going to check if pipes, now what's pipes equal to? Pipes. Let me go all the way back up here, right, where we called it. Pipes is equal to the pipes X position, okay? So, first I'm going to say pipes X, and maybe I'll change this. Double check we got that. Yep, all right. I am going to change this. Just for clarity, right? Because each one of these is really X pipes. It's the X value of the pipe. So we're going to say if the X value of pipes is less than 40, and I pick 40 because that is behind the bird, right? So, right, if it's less than 40, I know it has passed our bird. And I wanted to use 42 because we're using the X value of the pipe, and the X value is the top left corner. So I want to make sure the top left is passed. So if it's less than 40, right about here, right? And I can change that too. I might even want to say if it's less than 30 for a point. Maybe that's a little more reasonable, or 35. So I'm saying if the pipes is less than 35 now, and now I'm going to check, okay, if pipes is less than negative 50, so is it totally off the screen? If it is, change 400 minus pipes, which we are changing to X pipes for clarity. So change in X is not going to be equal to 0. It's going to be equal to 400 minus the original pipes value. Okay, and I'm doing minus because the original pipes value is going to be negative. So basically, I'm pushing it up 400, right? So this is going to be plus the original pipes value because I don't want to change how far apart the pipes are, and then I throw it over here. And so award points, award index, which is what this is. Remember, we passed the first one with a 0. Right? So pipes 1 and 2 have a 0, 3 and 4 have a 1, 5 and 6 have a 2. Because those are indexes. Arrays always start out with 0 index, so 0, 1, 2, true, true, true. And this is to prevent the bird from getting points every time the loop runs, because it will get like 1,000 points as it runs behind the bird, as the pipes keep going behind our bird. So what I do to control for that is I have that award point array. And then I set the indexes to be true at first for all of them, right? And so if first we find if the X of this pipe we're checking is less than 35, Then I'm going to check if it's less than 50. If it's less than 50, I need to loop the pipe and I'm done. If it's not less than 50, no. So it's less than 35, but it's greater than negative 50. Then I drop down to else if, and I'm checking to see if a point has been awarded yet, right? So if award point 0, so I'm saying, is this true or false? If this is true, that means I need to award a point. And then I drop down, I do award point 0 is now set to be equal to false. Score is going to get added, plus, and I update score. And then I return X. I return the change in X because if I do need to loop, remember it will just be set to 0. It doesn't change if I'm not below negative 50. If I do need to loop, I do it right here. So I didn't create a new variable because I'm just going to return the change in X and I tack it on here. And it's going to be 0, so there'll be no change if it's not needing to loop, but that way I can just have it right there. All right, and I do that for all of these. Then I'm going to check if pipe 1 and 2 is greater than 350. So am I off the screen, right? Randomize the height. And that's what makes the pipe's height change. Randomize height, randomize height, randomize height. So let's go find that function. The randomize height function, extra junk, pipe impact, randomize height. Yep, all right, so I take the top pipe and the bottom pipe. Yep, pipe 1, pipe 2, okay? So, and remember, they're both in arrays. And what I do now is I create this variable y pipes, and it's going to be equal to a random number 70 to 280. And then I'm going to set the property of type top pipe 0, which is going to be this top pipe, the top pipe, and then 0 is going to be the index of the array. What is top pipe? Well, that would be pipe 1 this turn, and bottom pipe would be pipe 2 at this point. So top pipe 0 for this pipe would be the tube of the pipe. Okay, and so I'm going to set the height equal to y pipes, whatever random number I got. Then I'm going to set the top pipe 1, right? So remember, arrays are 0 indexed, and then 1 is the pipe cap. I'm going to set that y value to be the y minus 20. And I'm saying minus 20 because then I cover up some of it, and I get the cap to cover up the end of the pipe. Now, for the bottom pipe, my bottom pipes are 400, I think, high. 400 pixels, 300 pixels. Yep. And that is because instead of changing the y value, instead of changing the height, because if I change the height for a bottom pipe, I'll never see it. Instead of changing the height, I adjust the y value by the same amount, which is like changing the height. It's pulling the pipe up as long as there's pipe all the way below. So I say plus 100 for this value because that always keeps the distance of 100 pixels between these two pipes. Okay, and then I say plus 80 for the pipe cap, right? For bottom pipe 1, obviously because it needs to be up. It needs to be up a little bit higher. So actually there's like 90 pixels between each pipe. And that's what's going to randomize the height each time. All right, now move pipe 1, X and, okay, so what I'm doing, I'm moving each individual pipe. And how I'm doing it, I'm using this X value I saved up here, right? Because I don't want to have to keep getting the pipe's X value. That's pretty labor intensive. So I get the pipe's X value. Well, I set the pipe's X value to start, and that's just what we use. So, all right, I pass the pipe's current X value, and then pipe 1 to move one pipe. Move one pipe. Because this is moving pipes individually. And all that is doing is it's grabbing our pipe array 0, so that's the tube of the pipe, X location. Right? So it's just updating the location. And X is getting changed as we do the time loop. I then pipe array 1, the 1 index for all of the pipes is going to be the pipe cap. And I do -5, so it hangs over a bit. Okay? So I'm just updating all of the pipes' locations. If collision equals true. So check collision. Check collision will return true or false. Check collision's right here. Variable collision equals false. Check for pipe 1 and 2 collision. Collision equals, so I have this variable, I set the Boolean equal to false. Boolean. Collision equals pipe impact, pipe 1, pipes 1 and 2. So here, I'm not using any parameters, I'm just checking each pipe. So I immediately say pipe impact, pipe 1, and then their x value, and set that equal to collision. Well, what's pipe impact? Here it is. What pipe impact does is, so collision is set to false. We're checking the individual values of each pipe. We're checking each pipe for collision. Variable y pipe cap is set to 0. So if the absolute value is less than 45. Now what absolute value does is it negates it, right? So, it gets rid of any negative signs, because I don't care if this number is negative or positive, right? I don't care if my bird, the back of my bird's wing hits this, that's game over. If the front of the bird hits this, that's game over. So if our bird is 30 from it here or 30 from it here and touches it, I want the game to end. So that's why I'm using the pipe's x location minus the player's x location, and then saying absolute value, because that will make it, regardless of whether that is negative or positive, I want to know if that's going to be less than 45. If it is, that means we've come in contact. Sprites are drawn from their center, or I guess images are drawn from their center, right? So 20 out is actually like the tip of his nose, to let you know. Okay, so if there is contact, so if I know the x is close, so if my player's x value is close to the pipe's x value, then I want to check, okay, well, is the y within the same area of distance? So y pipe cap, get y pipe 1, right, the 1 index, y value. So where's the current cap's location? If player is less than the pipe cap, okay, if player is less than the pipe cap, then collision equals true, right? So if player's less than the pipe cap and I'm that close x, that means I am somewhere up here because 0y is up there. So collision's going to equal true. Else if I'm not, if my player is greater than the pipe cap plus 70, then collision equals true, right? Because that distance was 70. And then collision will be equal to true. Then we're going to return collision. When we return collision, up here, if check collision is equal to true, right? So if we hit something, it returns true. If it's equal to true, then I want to make sure, yep, we check that pipe. We're using the, yep, pipe X. Got it. Okay. So we're checking that pipe. Check collision. Ah, there we are. Check collision. Okay. And so that would be the first pipe, right? So that's our first pipe and our first pipe X value. So maybe it returns false. We haven't impacted that pipe. If collision's still false, right? So this is a not operator. Again, we're seeing it. So if collision, so if this returns false, this is this negates it. So we'll say this is still false because the player hasn't hit the first pipe. If collision, well, collision's false. We haven't hit the first pipe. Oh, but not. So that makes it true, right? This is just the opposite. So if, okay, we haven't hit anything yet. Well, now let's check the next pipe and the next pipe. Then let's return collision. All right, and then we get back up here. If it's equal to true, if there's a collision, stop time loop. That's what stops this time loop thing from going so fast so often. Just get rid of it, stop it, and run game over. What does game over do? Well, there's actually a little bit of a time loop here too. And then it is y player equals y player plus 3. So we're pushing the player down the screen. If player is greater than 386, so if I hit the ground, stop the time loop. And that's the game over. if steps is less than 10, this is the stepping mechanism. So if steps are less than 10, player equals player minus 3. So how that functions, and then I update the player's Y so we move up. How this is functioning is I set steps equal to 20 at first in the game. Okay? And then when you click steps, every time you click the screen, you'll notice steps is equal to steps minus 15. And if steps is equal to steps minus 15, this is how big your step is going to be. So suddenly, each time we run through the loop, oh, steps is now less than 10. Okay, so we're going to take the player's Y value, subtract 3, set the player's Y value to that new thing, and increment steps, add 1 to step. And so this is how I am tracking if I have run steps enough to make sure that we get the player's Y value back up to where it should be. Meaning moving the player up the screen. And what's nice about this is doing it in the loop and adding it in this way means that it looks really smooth as we play. So let's play it again. Wah! Uh-oh. Bah! And so that's going to take us to here. And then game over, check collision, pipe impact. Yep, we got that. Randomized height. Yeah. So it does seem somewhat complicated at first, but honestly, when you dive in, it's not as bad as you think. The steps thing is super cool. It's one of the things I figured out later on because it really does allow for that smooth movement when a player would click on the screen, right? So if the steps is less than 10, well, the steps every time I click becomes negative 15. So if it's less than 10, I'm going to add to the player, right? I'm going to add y equals y plus 3. And so I'm actually moving up 3 pixels for each step change. And steps equals steps minus 15. So it just controls the range of it. Something I thought was especially neat. So, anyways, I'm going to play this one more time. Wada! Go, birdie, go. Oh. That was not a good round. But you should remix this. You should make your own. That's also, I can do better than that, I promise. You should remix. You should make totally your own thing. Use different creatures. Turn up the gravity. Make something better. Steal some ideas and go make something really cool. When you do, definitely post it below. Again, I'm going to post this, a link to this in the description. You can play some yourself and take a look at the code. So, yeah, it is awesome, and I can't wait to see the awesome things you make.